Hey everyone, welcome back. Today we're diving into something called the Model Client Protocol, or MCP for short. Think of it as the universal language that lets all these different AI models, tools, and servers actually talk to each other. It's kind of like the hidden grammar that's going to power the next big wave of AI applications. So here's how we're going to break it down. We'll start with why we even need a universal language for AI in the first place. Then we'll follow the journey of a message from how it connects to the formal handshake. After that, we'll get into the really cool stuff, the toolkit of what servers and clients can offer each other. And finally, we'll look at how all this could totally reshape how we interact with AI in the future. So what's the big deal? Well, just imagine your AI agent needs to use a new tool or pull data from some new database. Without a shared language, it's just chaos. Every single integration would have to be a custom job and super brittle. That's the exact problem MCP is here to solve. It creates a universal grammar for all these AI components to collaborate. At the end of the day, you can think of MCP as the official rulebook for how these AI clients and servers talk. It makes sure that when a client asks for something, the server knows exactly what it means. What you get is a really predictable and reliable back and forth, which replaces all that messy ambiguity with some much-needed precision. Now, what's really smart here is that MCP isn't reinventing the wheel. It's built right on top of a solid, super lightweight foundation called JSON RPC 2.0. By using a protocol that's already so well understood, MCP basically gets a pre-made grammar for structuring messages, and that makes it way, way easier for developers to just pick it up and run with it. Okay, so we've got the language down, the what of the conversation. But now let's talk about the how. How does a message actually get from point A to point B? Well, that's the job of the transport layer. It's the actual physical road, if you will, between the client and the server. And MCP actually gives you two ways for these messages to travel. For stuff happening locally, on the exact same machine, there's something called Stdio transport. You can think of it like passing a note across a desk. It's incredibly fast, absolutely zero network overhead. But for remote communication, there's Streamable HTTP. This is more like international shipping. It uses standard web protocols to connect systems across the internet, and you can even tack on security features like API keys. So once that connection is physically made, the real protocol kicks in. See, the client and server don't just start yelling data at each other. They have to introduce themselves properly first, and that's where you get this formal handshake. And this is what really sets MCP apart from, say, a simple web request. An MCP connection isn't just a one-and-done transaction. It's what we call stateful. That means it remembers the entire conversation from start to finish. And because it has this continuous memory, it needs careful management, which all kicks off with that formal handshake to create a stable, long-running connection. This handshake happens in a few key steps. First, the connection gets initialized. Then comes the really important part, capability negotiation. This is where the client and server basically lay their cards on the table and tell each other what they can do, what features they support. And once they agree on what they both can handle, the connection is officially established and the real work can get started. All right, now we're getting to the heart of what makes MCP so powerful. We're talking about the primitives. These are the specific things, the building blocks, that a server can offer to a client during their chat. So yeah, primitives are the fundamental pieces of the MCP conversation. A good way to think about it is like a restaurant menu. The server presents this menu of its capabilities. Those are the primitives. And then the client can just browse through it and decide what it wants to order, what information or actions it needs. And the server's menu has three main sections. First up, you have tools. These are actual functions the AI can run, like calling an API or querying a database. Second, you've got resources. These are data sources that give the AI context, like the contents of a file or a database schema. And third, there are prompts, which are basically reusable templates that help guide the AI's conversation. But here's the thing, this isn't a one-way street at all. In MCP, the client isn't just some passive customer. It can actually offer its own powerful abilities back to the server, which makes the whole interaction so much richer. So a client can offer some really powerful primitives. With sampling, a server can basically borrow the client's own language model to generate text without needing an LLM of its own. It can use elicitation to pop up a question directly to the end user, like, "Are you sure you want to delete this file?" And it can offer logging, which is just a way for the server to send diagnostic messages back to the client for debugging. Super useful. This table here pretty much lays out the whole conversational structure. And if you look closely, you'll see a pattern, right? Servers offer methods to list and get things, which lets clients figure out what's available before they do anything. Then you've got methods like tools/call that let the client actually execute something. On the other side, the client's primitives are all about making requests, like asking for text completion or user input. It creates this really elegant symmetry of discovery and execution, which makes the entire interaction super transparent and predictable.
Okay, so let's zoom back out for a second and look at the big picture. Why does all this technical stuff actually matter? I mean, what kind of future does this all lead to?
So here's the main takeaway. By standardizing how everything communicates, MCP lets developers build these powerful AI systems like they're snapping together Lego bricks. You can just plug a new tool or a new data source into your AI agent, and because they all speak the same language, it just works. This is what unlocks a future of truly modular and interoperable AI. And this whole ecosystem isn't static either. The protocol actually supports real-time notifications, which means the entire system can be incredibly dynamic. So if a server suddenly adds a brand new tool, it can instantly tell all the connected clients, updating their abilities on the fly. This lets our AI applications evolve and adapt in real time, which is just amazing. And that leaves us with one final thought. As AI systems get more and more decentralized, made up of lots of specialized agents, models, and tools all working together, having a universal language stops being a nice-to-have and starts becoming an absolute necessity. So the real question is, will a protocol like MCP be the key that finally lets all these different pieces connect and unlock their true collaborative potential?